Hi, it's a group of students presenting gap phenomenon in stock market project. My name is Alexander Shashkov. I am an IIT student pursuing master degree in artificial intelligence, and he is my project partner.
Hello, my name is Santosh Chelvaraju and I'm pursuing my master's in data science at Illinois Institute of Technology.
Yes, and this project is an attempt to explore the price gap phenomenon in US stocks, identify relevant parameters, correlations, and/or causative relationship, and build a model capable of um, predicting stock prices movement following gap occurrences. It seeks to address the following questions. What are the factors contributing to the gap formation in stock market? And are there any behavioral patterns in stock prices after the gap within the 10 days time frame? If so, can they be classified and exploited? On this slide, you could see the picture of virtual stock price movement in Japanese candlestick form, and there are shown some gaps, different types of gaps that we were able um, to figure out to find in the literature and in the reviews. So in order to accomplish the goal, we decided to explore gaps in prices for the stocks of the US companies historically belonging to S&P 500 index. Our search for previous work and literature led to two sources. The first source that caught our attention is the book Technical Analysis of the Gaps, Identifying Profitable Gaps for Trading. The authors of this text concluded that there are certain relationships between gap types, their parameters, circumstances in which they occurred, and expected returns. The authors warranted the further exploration of the gaps. The second source was an article published in Investment Analysis Journal. Authors used descriptive statistics and regression analysis in attempt to test several hypotheses associated with prices behavior in the gaps and after the gaps. However, the choice of financial instruments and the formulation of hypotheses didn't allow us to understand if it was possible to conclude regarding whether or not gaps represent the opportunity for better than normal returns. Hence, we embarked on our own research. And now I pass the word to my partner to explain what data and we used and how we got that.
Yeah, thank you, Alex. So coming to the data part and the data preparation part. So one of the major challenges that we encountered while getting historical constituents is having a data set that is survivorship bias free. So the original list of constituents is basically a download associated with the book called The Trading Evolved. So there is a download associated with this book called Trading Evolved, and so we'll be using that. So it has a list of constituents which runs from 1996 to 2019. So since 2019, the list has been updated using the Wikipedia page, which has a list of stocks which are part of the stock index, that is S&P 500, that is a US stock index. So in this list, if there is a ticker which is first found in the list and later if it's not there, it could be for two reasons. So coming to the first reason, it could there could have been a scenario where the stock could have been removed from the S&P 500 stock index, and the other reason could be that the company could have been acquired by another company, so the ticker name changes. So basically what we're doing here is, we prepare a dictionary here out of the CSV that we have, which has a list of historical constituents. The dictionary consists of the ticker names as the keys and the values as the list of time frames for each ticker from 1996 to uh, to the current time, that is 2022 July. So it basically has a list of time frames for each of these tickers, which is basically a list of lists, and the dictionary is later utilized to download data for each of these stocks and save it as separate CSVs. So how we found out this list of historical constituents is through one of the online sources, which we happen to, in one of the blogs, we happen to see one of these GitHub repositories which had this data, and how the data was acquired. And so since we're looking for free sources to uh, looking since we were majorly looking out for free sources to get the data, and this was one of the best options that we had at the moment, and we went on with it. So coming to the so Alex, I think you can go to the next slide. So coming to the data selection part, so once we have the tickers, our dictionary ready with all the tickers and their respective time frames. So the next thing that we have to do is get the individual stock details for the respective time frames, and to achieve this, we had to resort to one of the free sources outside. So we happen to use Yahoo Finance for this. So the historical data for each of the tickers is downloaded from the public source, that is Yahoo Finance. So each of these data that we are downloading from Yahoo Finance has parameters like open, close, high, low, volume, and adjusted parameters for each day uh, for the respective time frames. So if a stock has multiple time frames from 1996 to 2022, so all of this data is compiled into a single CSV, and it is saved in one of the folders in our project directory. So since we have the data now for each of these stocks, and the next job would be to carefully analyze and carry out the cleaning process before we step into the modeling. So coming to the data preparation part, yeah, Alex, let's move on to next slide. Yeah, coming to the data preparation part. So we have around 600 CSV files for each of these stocks. And it's also true that for some of these stocks that we had listed, uh, we failed to get the data from the free sources that we had. So, so continuing with the data that we have acquired so far. So here we using the metrics that we already have, that is open, close, daily high, daily low, and adjusted and volume parameters. We are calculating some of the other parameters as well, which we are later going to use it in the data analysis part. So before going there, so the first thing that we do is the very basic things is do the very basic cleaning process on each of the CSV files. So the first thing that we do is we are basically going to remove the files which have very minimal data. So as Alex already mentioned that we are going to the prediction is going to happen based on the data post the gap, 10 days post the gap, and 10 days before the gap. So if there is a stock file which has rows less than 25, so we are going to basically delete those files because there is no point. the data that we have for that stock is of no use for us in the data analysis part. So that is one of the things that we do in the beginning, and later we remove all the rows with NA values. So some of the rows and for some of the dates, some of the values like open, close, or high, low parameters had a lot of NA values in the data that we had. So the next thing that we did was removing those rows from the data, and some of the files which we downloaded also had no data at all. Not even a single row of data was there. So even those files were removed. So using the data that we have so far with the parameters that I've already mentioned, we'll be calculating some of the other parameters as well, and storing them as new columns, and we'll be using them as features in the data analysis part. So some of the features that we calculate, or the variables, new variables that we introduce, is the gap type. First of all, we go on finding the gaps, and once we have the gap, we try to find out what type of gap it is, and then the size of the gap is calculated. So is it a up gap or is it a down gap? So all of these things are calculated and is stored in one of the columns called gap type, and the gap size is stored in the column called gap size. So we have a list of formulas for all of these, and we have these formulas listed in our project report. So the other parameters that we calculate are the volume change, the overnight returns, and relative daily price range, day of the week, and month of the and the month. So we are also considering the day on which the gap had occurred, and also the month corresponding to that, and the candle body metric, and uh, and the lags and leads after and before the occurrence of the gap. So we are considering 10 days of lag and 10 days of lead. So for each of these 10 days, the volume change, return, adjusted return, range, weekday, month, candle body metric is calculated and stored in respective columns. So once we have all of these CSV files with all of this data with old and new metrics, now we have to combine all of this data into one single data frame and store it in one single CSV, and we call that as the final pre-processed data, which is later used in the analysis part. So that is with the data preparation part of the project. I think Alex can take it over from here.
Right, thank you. So after the data cleaning and pre-processing, we ended up with substantial data set. Over the course of 2 decades, almost 2 decades, and with the partially removed survival bias, and the total number of gaps we detected was 117,207 gaps. Out of those, there were up gaps, 64,130, which accounted for 54.7%, and gaps down were 53,077 gaps, which is 45.3%. Having this data, we explored the distributions and relationship of different parameters. For example, it can be noted that considerably less gaps of all types occur on Wednesdays. Monday, Tuesday, and Thursday are the most productive days for the gaps. The last 2 months of the year are less productive on gaps, as well as July and September, October are the most productive months instead. Gaps up have spikes in April and October, and gaps down are more frequent in May, June, and August and September. The distribution of gap size have few very far outliers, which will be candidates for removal from the data sets later. The distribution for the remaining 95% of the population showed that the majority of the gaps have size smaller than 3%. The daily price range for the gap, they has a small number of very far outliers too. The distribution of those remaining 99% of the daily range population showed that the majority of the daily ranges lay within 12%, and the most common range is between 1 and 2%. We also performed correlation analysis, which led us to several findings and conclusions. The returns are strongly correlated with open-close range. This makes sense, as most often overnight returns are strongly correlated with daily returns. We will keep it in mind, as potentially it may suggest removal of irrelevant predictors. The other observation was that the returns are strongly correlated with the size of the gap. This also makes sense. However, the size of the gap may represent not just a change in the price, but the influence of significant forces moving the price. Therefore, we're probably going to keep this as a predictor. The other observation is that the daily price ranges have significant autocorrelations, and most of the other variables have insignificant and very short autocorrelation effect. Just for 1-2 days, it's noticeable, then it disappears. That is only with the exception for daily price range that was mentioned earlier. This information might be useful in attempting to narrow down the size of the lag considered in time series related regression model or recurrent neural network architecture. So next is a few words about modeling that we performed. We decided to first proceed with building linear regression and considering all the features, including all the lagged values going back 10 days. In a sense, this is an ARMA model with an added mix of static features that don't have a lag. The idea was to see the performance of such a model and to estimate the significance of the predictors within the linear regression framework. One second. The resulting linear model produced extremely low MSE. However, the R-squared metric was very low, suggesting that the linear regression framework might be inappropriate for the task at hand. Our next step was to apply the lasso regression model in an attempt to perform feature selection. Search for optimal lambda parameters was performed automatically. This feature selection technique produced similar results as with a simple linear regression model. It seems like past values of volume change do not play any role in predicting feature return, and all other predictors do not demonstrate predicting power past the lag of 2 days. However, this is based on the assumption of linear relationship. We do expect non-linear relationship, though. Therefore, it would be reasonable to still maintain the entire set of predictors to evaluate non-linear or recurrent models. Our goal was to design, implement, train, and test the model and evaluate its performance based on recurrent neural networks. However, due to the lack of time, the learning curve associated with time series that we need to take, and survival bias removal struggles led us to limitation in time, and we were unable to finish modeling as initially was planned. Therefore, if we had an opportunity to take this research work further, here are the further recommendations for and the requirements. We would like to obtain more complex and more complete data, specifically for the stocks of the companies that were in the S&P index for the period of our interest, but delisted or ceased to exist or were absorbed or acquired somehow. We were unable to completely remove survival bias, but partial. Then we would like to implement recurrent network architecture and evaluate its performance. And if successful with recurrent neural network for predicting for 1 day ahead, we would like to extend the model to predict returns for more than 1 day ahead. That's basically it. That's the summary of our research, and we thank you for your support and consultations that you provided. And we are looking forward to continue the research if possible. Thank you.
Yeah, thank you so much.